In this next video, again, it's kind of a review of decimals, looking back specifically to, again, the numeration, reading small numbers, but I'm hoping you're noticing the connection between the language of decimals, as well as the concept, and the language of fractions. I hope you recognize this guy here as our place value chart. He'll definitely be very helpful, or it will be very helpful for this next part. So our example says, write 74 3/10 as a decimal number. So I'm going to write that into my chart. 74, 7 in the tens, 4 in the ones, and 3/10. Notice I'm writing my 3 in my tenths column. So really straightforward, 74.3. Just for your review, 74 whole and 3/10 is how that would look as a fraction. Next example, write 96 2/10 as a decimal number. So again, 96 2/10. Be careful, that's the part that sometimes messes kids up. So 96.2 is our answer, but thinking in terms of mixed numbers or fractions, 96 whole and 2/10. Same thing, different way of writing it. In this example, it's asking us, in 0 and 64 hundredths, which digit is in the tenths place? So I've started by writing it into my place value chart. I've noticed where the decimal is. I've written that there. The 0's on the left, then the 6-4. And then I look, obviously the 6 is in the tenths place. I feel like they've tried to make this one look a little scarier, but it is exactly the same thing. In 7,315 and 68 hundredths, which digit is in the tenths place? Same thing, I wrote it in, taking note, where is my decimal, and writing the numbers accordingly. And then I look, tenths, it's the 6. Ms. Cooper, how could I do this without writing it in the place value chart? Well, hopefully you get familiar with the idea that just to the right of the decimal is the tenths column. So it's the 6. In this next example, they've tried to address a really common mistake for kids. This is kind of a tricky concept. It's sort of looking at equivalent decimals. So it's asking, are 0 and 9/10 and 0 and 90 hundredths equivalent decimals? It's tricky because our immediate reaction is 9 and 90 are different numbers. If you write it on the place value chart, however, I'm hoping that you'll recognize that in both 9/10 and 90 hundredths, we have 9 in the tenths column, and really there is an invisible 0 here in the hundredths column for the 9/10 anyhow. We're saying this number is 0 whole, 9/10, and nothing else. There's no hundreds, no thousands, no 10,000s. In this number, we're saying the same thing. There's 0 in the whole, or 0 in the ones. There's 9 in the tenths. There's 0 hundredths, and again, invisible 0 in the thousands, invisible 0 in the 10,000s. You can see I've added here some more examples and equivalent fractions. We continue to see 9 in the tenths column, and I've just added as many zeros as I felt like after. It doesn't change the fact that this number is, these are all equal. They're really just saying this is 0 whole and 9/10 and nothing else. I'm hoping this doesn't confuse you, but I'd like to introduce the fact that where it does get different is if we put the 0 between the decimal and the 9. Because what we've done is now we've changed it. We've said, no, there's 0/10 and there's 9 hundredths. So I think you'd recognize the fact that a tenth is bigger than a hundredth. They're not the same thing. So even though these ones at the top here in black are all equal because they're all 9/10, the one in red is not equivalent because there's 0/10 and 9 hundredths. Another way to prove that these two decimals are equal to you is to look at the fraction model. We know 9/10 is illustrated in a fraction model as 9 colored in, and where 10 is the whole, and 90 hundredths has 90 colored in, where 100 is the whole. And just like when we looked at our equivalent fractions, we can see that these two numbers are equal, these two decimal numbers or fractions. Notice I've written their fraction equivalent here as well, are equal. We've just split all these sort of rectangles into many more, but the proportion of the whole is still the same. There's still the same amount of blue colored in. If you split a pizza into 10 pieces and asked for 9, you'd get the same amount of pizza as if you split it into 100 pieces and you asked for 90. They are equal. The last thing I want to point out when we think about the connection between the fractions and the decimals and considering whether they're equal is if we think back to when we made our equivalent fractions. So 9 tenths we're saying is equal to 90 hundredths, and it's obvious because 9 times 10 is 90, 10 times 10 is 100. So these two are equivalent fractions, and therefore they are also equivalent decimals. So our answer is obviously yes. This is the last example I'm going to show you in this video. It asks which decimals are equivalent to 5 and 4 tenths. Choose all that apply. I like this visual of lining it up on the place value chart, and I actually think this is quite a simple question. I hope you understand and recognize immediately that 5 and 4 tenths is not equal to 5 and 7 tenths, so that one is out. You might then say, oh, but yes, 5 and 4 tenths, I see again here 5 and 4 tenths. There's a 0 though that makes it different here in the hundredths, but oh yes, there's an imaginary 0 here. So yep, that guy is correct. Going back to this one, 5 and 4 tenths is not the same as 5 and 5 tenths. And lastly, 5 and 4 tenths is not the same as 5 and 9 tenths, or sorry, 5 and 90 hundredths, but still we see that 9 in the tenths column, which is different than the 4. So the only answer that is equivalent is 5 and 40 hundredths, because we see that same 4 in the tenths and 0 in the hundredths. Okay, good luck with this section.